All right, so exercise 8F, tree diagrams. So our learning intention today is to find probabilities of events using a tree diagram. So last exercise we used a table. Now we're using tree diagrams. To activate your prior knowledge now, I'd just like you to take a moment, pause the video. Can you remember what the following words mean? Event, given that, with replacement, and without replacement. So take a moment, try and remember. If you can't remember, check your notes and find the answers. So pause, and then let's come back into our learning for today. So we're looking at tree diagrams. So last exercise, we were looking at two-step experiments using tables. So multi-step experiments is when you've got two or more steps in your event. So for example, flipping a coin twice or three times would be a multi-step event, where flipping it only once would be a one-step event. The good thing about tree diagrams is we can use them for any multi-step experiment. So with tables, we can only use them for two-step, because the horizontal will represent the first step and the vertical will represent the second step, or vice versa. But you can only have two steps. Tree diagrams, we can do as many steps as we want, as long as it's still practical to draw. The good thing about tree diagrams is they give us a systematic method of identifying the sample space. So what I mean by that is you're going to get all the possible options. You're not going to miss any. And the good thing about tree diagrams as well is when the outcomes aren't equally likely, they can help us calculate probabilities. So with the tables, we really only use, like we did last time, it was only for when they were equally likely. So this one's going to help us when they're not equally likely as well. So once you've got, this is an example of a tree diagram. So what we've got is the start of our experiment. And then you can see on our first flip, the two options are head or tail. So this first branch really represents the first flip. And then we branch off again, and these options here represent the second flip. And then we follow along. So if we go heads first and then heads, then we've got two heads. But if we get heads first, we can also get tails. So that means heads and tails. So here's our list of all the different options. And then if you want to figure out the probability, you can multiply the probabilities along each branch. So the first flip, you've got a 1 in 2 chance of getting either option. So probability of getting a head is 1/2. And then probability of getting a head is a 1/2. So you do 1/2 times 1/2, 1/4. Next, we're going to have a shot at filling in a tree diagram for I'm going to have a shot at filling in a tree diagram for an example. So try and fill this in. I'm going to fill it in now. If you're not sure where to start, feel free to listen in as I go through. So here we've got our first, so this is for flipping a coin 3 times. Here we've got our first toss. So our options are head and tail. And then we've got our second toss. And your chances of getting a head are 1 out of 2. Chances of getting a tail are 1 out of 2. Second chance, second toss, we can get, if we get a head on the first one, we can still get a head or a tail on the second one. And it's still a 1 in 2 chance of either option. The coin doesn't know that it's already got heads, so these are independent events. The probability of getting a head on the first toss does not change the probability of getting a head on the second toss. And again, we've got heads and tails and probability of half along each branch. When you're setting these up, leave yourself plenty of room. It's so easy to run out of room here. I know some teachers like to do these vertically, and if you like that method, you're welcome to use that too. What I mean by that would be something like setting it up like this. So you can use that method as well if you like it better. It is sometimes a little bit easier because you can always go down the page if you need more room. Now we're going to go along the branches and list our sample space. So this first option is head, head, head. And we've got head, head, tail. I might calculate our probability as we go. So you multiply each branch. So I've got 1/2 times 1/2 times 1/2. So the numerator, 1 times 1 times 1, 1. And denominator, 2 times 2 times 2, 2 cubed, 8. And we can see we've got 1/2 times 1/2 times 1/2 again. And so we're going to get 1/8 for all of these. They're all equally likely. I'll show you one where they're not equally likely later. All right. So now we're going to calculate some probabilities based on our tree diagram. Doing the tree diagram is normally the hard work. Now we've just got to interpret this information to come up with our answers. So let's have a look. Given the tree diagram, calculate the following probabilities. So probability of getting 3 heads. There is only one option here with 3 heads, and we've already calculated the probability. It's 1/8. Or the other way of thinking about it is there's one option out of 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 possible options, 1 out of 8. Now we've got no heads. So the probability of getting no heads, there's only one no heads. There's only one option with no heads, 3 tails. So this one again is 1 out of 8. Now we've got exactly one head. Exactly one head. Oh, actually, I've already used that color. Exactly one head. Let's go pink. So now let's have a look in our sample space and see how many we can find with just one head. So we've got this one, which is just one head. And we've got this outcome, which is just one head. And we've got one more, tail, tail, then head. So there's 3 possible outcomes out of 8. Or the other way of thinking about it is adding these probabilities together. So we've got the probability of this one, which is 1/8, plus the probability of this one, the tail, head, tail, which is 1/8, plus the probability of tail, tail, head, 1/8. So we got 3/8. Our final question here is probability of getting at least one head. So that means we could get 1 head, 2 heads, or 3 heads. So we'll have a look in our sample space and see how many we have that have at least 1 head. So this one's got 3 heads, so that one's good. 2 heads, we're going to include that one. 2 heads, we've got 1 head here, 2 heads here. We've got 1 head here. And we've got 1 head here. So we've got 1, 2, 3, 4, 5, 6, 7 out of our possible 8 outcomes. Or we've got 1/8 plus 1/8 plus 1/8 plus 1/8. One, two, three, four, 5, 6, 7. 7/8. Or the other way of thinking about this could be the probability of getting no heads and at least 1 head are going to be complementary. So maybe some of you thought about this one as being equal to 1 minus 1/8 from the no heads, because you know those two are complementary, so they must add up to a whole, or 8/8. Either way works perfectly well. All right, so that's how you do something like this, where the outcomes are equally likely. You're going to get the same probability for each outcome. So let's move along now to something where you don't have the same probability for each outcome. Now, Mr. McIntyre actually made these slides, so I'm still using his example here, but I did update it for our current situation, which is that next year there's going to be 4 Year 11 methods classes and 3 Year 12 methods classes. I don't know how many Mr. McIntyre is going to teach, but this is for the example. So we're going to try and use a tree diagram to represent this sample space. This time we're going to let T represent the event of getting Mr. McIntyre as a teacher, and not T, or the complement of T, not getting Mr. McIntyre. And we're going to assume that the events are independent. And that's probably true. Like, having him in Year 11 doesn't impact the chance of someone having him again in Year 12. So we're going to call this first one Year 11. So in Year 11, Mr. McIntyre teaches 1 class, and there's 4 classes in total. So your chances of having him in Year 11 are 1 in 4, right? And then your chances of not having him are 3 out of 4. Now let's call this next branch our Year 12. So if you have him in Year 11, you're either going to not have him or you're going to have him in Year 12. So in Year 12, there are 2 Year 12 methods classes, and he teaches 1. So you've got a 1 in 2 chance now for each option. So now we want to list our sample space. So you follow along our branches. And then we want to write our probabilities for each one. Now, this can be tricky, especially if you are not so flash with fractions, and a lot of students aren't, so really take your time here and make sure you get them correct. So let's go ahead and multiply along the branches. So the probability of getting in both times, we've got 1/4 times 1/2. So that would be 1 over 1 times 1, and 1 out of 8. And now we've got 2 times 4 again, 1 out of 8. Now we've got 3/4 times 1/4. I might even just show the working out for this one. You can do this as an aside. Remember, we times the numerators, so that's going to be 3 times 1. And then we times the denominators, so that's 3/8. And now we've got 3/4 times a half. Now, in this case, we don't need to simplify, but if you can cancel any common factors here before you multiply your fractions, it's a good idea. Keep the numbers nice and small. Good skill to practice for our calculator-free exams. And then again, it's 3/8. So now we've got our tree diagram. The hard work is done. Now we've just got to interpret it to come up with our answers to these questions. So find the probabilities of not having him in either year level. So that would be this one here, the 3/8. Bam. The tree diagram makes it so easy. Having him in year 12 only. So that is year 12 only. So the first listed is year 11 and the second listed is year 12. So that would be this option here. 3 out of 8. Having him at any year level. So that is either or both. Let's have a look. So that would include this one, which is both. This one, which is year 11. And this one, which is year 12. So we've got 1/8 plus 1/8 plus 3/8, 5/8. Okay, now our next example is without replacement. So now the probability of your first outcome is actually going to impact the probability of the next outcome. So let's draw our tree diagram, and feel free to have a go at this on your own and then check to see what I get. So this time we have we've got a bag. I might even draw our bag over here. So we've got a little bag, and in our bag we've got 3 red marbles, we've got 2 yellow marbles, and 6 blue. All right. So we want to use a tree diagram to represent this information. We are going to make 2 selections. We're going to have our first pick and our second pick. So on our first pick, we could get a red one, a blue one, or a yellow one. So let's call this our first pick. And then we've got, now let's figure out our chances. Our chances of, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We've got 11 marbles in total here. So we got a 3 out of 11 chance of getting a red one, a 6 out of 11 of getting blue, and a 2 out of 11 of getting a yellow. Now let's show our second pick. So our second pick, if we get our red one, our second pick, we could get red again, or blue, or yellow. And we could get red, blue, yellow again, red, blue, yellow. But let's see what happens to our probabilities now. So let's think about this. So what's happened now on our second pick? Our first pick, we picked a red one here. So now there's only 10 marbles left. And now there's only 2 red ones left. So now we've got a 2. Ooh. Have I left myself enough room here? It's always tricky. So now I've got a 2 out of 10 chance of getting a red one. And I'm going to simplify that fraction to 1/5. Next. So I've picked a red one. So now I've still got 6 blue ones left. So we got 6 out of 10 of getting a blue. Which is 3/5 of getting a blue. And then our chance of getting yellow are 2 out of 10, which is 1/5. Let's keep going. Now we'll go to our second branch. So we'll put that red one back in. And now what's happened is we have picked a blue one first. So we'll get rid of our blue marble. And so now we've still got, now our chances of getting a red one on our second pick are 3 out of 10. Our chances of getting a blue one now, there's no longer 6. Now there's 5 blue ones. So 5 out of 10, or 1/2. And then yellow, we've got 2 out of 10, or 1/5. Okay, now we'll go back to our third option here. So now we're saying in our first pick, we picked a yellow one. So now we're saying that our chances of getting a red are 3 out of 10. Our chances of getting a blue are 6 out of 10, which is 3/5. Our chances of getting a yellow, now we already chose one, so there's only 1 out of 10 left. Now we'll write in our sample space. So we've got red, then red, red, then blue, red, then yellow, and so on. So now we've got to find our probabilities along each one. So I might even show the working out here to find the associated probabilities. So we've got to do the two fractions multiplied by each other. So the first one, we've got 3 out of 11 times 1 out of 5th. Not noticing that simplifying it down is going to make it easier. So we multiply the numerators, 3 times 1 is 3, and then the denominators, 11 times 5 is 55. So we've got 3 out of 55 for the first one. Next one, we've got the numerators, 3 times 3 is 9. 11 times 5, 55. Now we've got 3 times 1 is 3. 11 times 5, 55. I'll show you the next one again just because I want to model how you can make this easier for yourself. So this time we've got to do 6/11 times 3/10. So remember, when you're cancelling fractions, you can cancel in a bow shape. So I can see I've got a common factor of the 6 and the 10. So to keep the numbers small and easy, I'm actually going to cancel this down first. So divide that by 2 is 3. Divide that by 2 is 5. So we get 9 out of 55. Again, next one is 6 out of 11 times a half. So we get another little opportunity to cancel down here because we've got common factors. So this one's 3 out of 11. So that one's pretty common compared to a lot of the others. And then we've got 6 out of 55. Just multiplying the probabilities along the branch. I'm running out of room here, so do make sure you leave yourself enough space. Again, I've got a nice fraction I can cancel. So 3 out of 55 for that yellow, and then red. Yellow, then blue. 2 times 3, 6. 6 out of 55. And then I've got 2. I know we can cancel this one as well. One out of 55. That must be the least likely. And it makes sense because they were the least yellow of any. Maybe I'll put our yellow ball back in there just so we've got our good diagram. All right, we've done the hard work. Now, if you're in a test, you probably don't even need to calculate all the probabilities here. You could just calculate the one that you need. But because we've got plenty of time and we're not in test conditions, we can take our time. And another good thing here to check our fraction work is that all these probabilities must add up to 1. So we could do a quick check here and just check that all these add up to 1. And then if not, go back and check our fractions. I'm feeling pretty confident though, but that could be a good way to check. And I feel like, I've taken long enough, so let's keep going. Now we got to find the probability of selecting 2 red balls. So let's check our sample space now and see if we can find 2 red balls. 2 red balls. There's only one. We've already done the work. It's 3 out of 55. Exactly one blue ball what do we got for that one? We've got this option here. We've got blue, then red. We've got blue, then yellow. And we've got yellow, then blue. So for this one, we've got 9 out of 55, 9 out of 55, 6 out of 55, 6 out of 55. Nice, they're all on a common denominator, so that takes out some of the work. So we're going to add these probabilities up for the different options. So 9 plus 9 is 18. 6 plus 6 is 12. So we got 30 out of 55, and we always want to give our answer in its simplest form. I'm noticing both of these can be divided by 5. So 6 out of 11. A yellow ball followed by a blue ball. There's only one of those ones. That's this one here, yellow then blue. So that's just 6 out of 55. At least one yellow ball. So let's see how many have at least one yellow ball. So we've got this option, and then all of these. Nice. Again, all of these are on a common denominator. They're all out of 55, so nice and easy to add up for our fractions. So we've got red yellow, which is 3 out of 55, blue yellow, which is 6, 3, 6, and 1 out of 55. So 3 plus 6 plus 1, that's 10, plus another 9, 19 out of 55. All right, good luck with the questions on this exercise. We'll save the review for class. Good luck.